That's me. GitHub, Twitter, same thing. Yeah, just kind of like, because this is more of a keynote, so I thought that I might like opine about Python a little bit. So like my first Python experience, I don't know like where all you started. It's like Python 2.5, so it was like kind of early 2008. I heard Python 2.6 was coming soon. I think that's roughly about the correct time. And I was just like using it, because I thought it might be interesting and it might be a quicker way to iterate and develop some code. So, I basically wrote some little replacement program for this test fixture that even my boss could update, which kind of, he was like, wow, this is easy. I don't know if anyone's used lab Windows. It's horrible. And like kind of, since then, like, I took that kind of germ of Python knowledge, ran it through to like grad school, where I was in a lab where we basically gave C. elegans, which is this tiny little worm. We'd give it drugs and use computer vision to look at it, and then we could use Python to process the computer vision data. We could do analysis on it with NumPy, SciPy, Pandas, and then from there, moving to I went to Argonne, which is a national lab in the United States, and we basically provided bare metal clouds for researchers. So, from data analysis, from test fixtures onto real-time applications for clouds. Using OpenStack, so that was, I don't know if anyone's familiar with that as well. And now, now I'm at Telnix and I'm using Python to power communication services. So, throughout my career, which is, it's like basically about 12 years of Python or so, I've been able to kind of use it in all these different contexts, which has been fantastic. So, regardless of what you're doing today, like you can kind of, do some data analysis on the side, at your company. Like if you're, wondering like, how's the usage changing over time? How's, the behavior of your users like fluctuate during the day? You can, quick pop from doing some applications stuff over to just like some data science. Use IPython notebook and like matplotlib, quick present something, and just kind of, through this, being able to just use one language to do everything has been like fantastic, versus R and Go and everything else. So, love Python. But yeah, so this talk is about magic methods. Why do you care about magic methods? So I guess what are they? In Python, everything's an object. So every time you're doing a lot of kind of ordinary like syntactic things like getting a dictionary item, looping, even checking if something is equal to something else, behind the scenes, Python will basically be calling these magic methods, or I guess formally special methods behind the scenes for you. And then like when you kind of embrace them fully, you can kind of be the duck, and that way you can pretend to be like other things. So magic methods are these. These are most of the magic methods. I can stop right here, right? No. Kind of, they fall into like a couple categories. I'm sure that everyone has, once they start doing object-oriented programming, they'll be using init a lot. Init is what controls the kind of initialization of objects. There's like other blocks for doing kind of binary operations, like the so-called infix operators. Augmented assignment is like A plus equals B. If you're doing kind of things with containers, like this is a fantastic set to use. Attribute access, this is like a little more kind of fun high-level or low-level stuff. Unary operators, context managers, async stuff. I don't know if anyone, like who actually got to the async workshop that we were running? Out of curiosity. Okay, about a dozen. Looks cool. Yeah, comparison. Like this is them. So, and all of these basically have like a syntactic component behind them. So the nice part about them is that like they provide this like very clear way to split the concerns of like what your code is doing and like how you might think about your objects from like the user actually needing to like do it themselves. Like if they're doing an inequality, you can basically tell them how that inequality works, and they just do less than, and then it's done for them. And then like once you kind of embrace that and like you implement these, then you can basically duck type. So you can pretend to be objects that are maybe not expected, but they will act the same way. So yeah, even something as simple as like a plus b equals c. Behind the scenes, what it will do is call a.add b to just kind of add those together. So that's the method on a that it calls. All the kind of infix operators are very similar. You have true division. There's also like floor division, which is the old Python 2 one, which is dying. It's great. Multiplication, matmul. Matmul, I don't know if anyone uses NumPy, but there is no matmul in the standard library. It was just for NumPy. But that also means that you could use it for something clever. Don't be too clever, though. For looping, for x and y, it's doing something like this for you behind the scenes. So it's calling iter on it, and then it's pulling items out of that. But I'd rather just write the for loop, and like a lot of people would as well. And the for loop works if you pump it into, for instance, a list. If you pump it into a set, it will just kind of pull out items from that iterable. Context managers are great. They allow you to basically take care of the kind of crash handling, separate from everything else. So like the user that might be, kind of calling something with your object or doing something with it, if you need to actually free up the resource, you can make sure that you do that and not like worry about it. So kind of what these methods allow you to do is act like certain objects. So there are, kind of certain operators that you can do, or certain operations that you can do with certain types of objects. For instance, lists, you can add them, you can reverse them, you can index into them with typically integers or integers. You can see if certain items are in them and their length, and you can iterate over them. But there's other things, like for instance, addition you can also do with numbers. You can add, or you can do like inequalities with numbers and sets. So you can kind of subset things and check if they're like check if they're subsets, or check if something is like fully contained within another set. Int float, generally more number type things. You can iterate over a lot of these. So, but all of these actual syntactic methods are behind the scenes just one of these magic methods. So if you implement them, you can actually kind of pretend to be, one of them. If you implement getItem contains len iter, you can basically be that dictionary as far as like anyone else cares. So, all right, that's enough like slides, and let's actually get into live coding, which is usually comedy gold. So yeah, magic methods. So, to underscore it, there's magic in everything. You can't not use magic methods. So when I instantiate my object here, I called init on it. Object init doesn't do anything by itself, but I could implement it. If I just, for instance, print the object, or not print the object here, if I just like say object in the REPL, it doesn't know what to do with it, so it just basically calls this repr on it. So for debugging, it's very nice to implement repr just to kind of get some more information when you do this. If I print it, it'll actually call the string on it, which in this case it falls back to repr because there is no string defined on the object. So that's like these very kind of simple methods. You're already using magic methods. So like we can kind of jump right into it with repr and string, which are really kind of helpful when you're just kind of like debugging things. So your code never actually has to call these, but it might be handy if you're just like, what's going on? How's this working? If you want to drop into a debugger, you can just like say like print the database connection and see like its state, like where it is actually connected to, like how many like connections in the pool. Like a lot of this information that you might want to kind of dig around and like poke at, you could just like have it print for you, which is fantastic. So here I'll define just like this stringy class. The documentation for all these, so like we go here, this would be the, like I'll provide this for you, but the documentation for repr just suggests that it should be something that you can kind of round trip with, and if it's not possible, just something useful. It completely is up to you. And string is whatever you want. So it's, so here if I have stringy apple, right here what this did when I just said a, it called repr on it. So that's the same output as this. And I can also round trip it. So if I evaluate the output from repr, I get back basically the same object, which can be handy. If you can't do that, that's why the kind of this bracket notation is suggested. And that's what you'll get up here, because it's just some object at some memory address. And if I print it, the print will see that it's an object and just call string on it for me. So, some from Java might just be like, oh, well, I can do that too. I just implement toString on it. And it's like, okay, great. Yeah, now I have some object there that I don't know, it's maybe obtuse what it is. And look, yeah, I can do the same thing, but when I print it, it's not all nice for me. So why you would not want to do it, it's non-standard. Python already has a way to do it. It's the way that everything expects. And if for in this case, if you wanted to format it or do something, you can implement another magic method. But by kind of just going along with the flow, it's a Python idiom. It's the Python language makes it available for you. You should try to use it. Something in kind of maybe a little more rich here, we can kind of look at our container methods that we're discussing. So something that it's kind of fun, when you prepare these presentations, you're like, oh, it'd be cool to do this thing, and then you discover that you built something that was already in the standard library. So we're going to implement something that's already in the standard library that I found out after I did this. So it's called the chain map is what the library calls it, and I called it a fallback dict when I started it. So it's kind of handy if we have a bunch of dictionaries where it's maybe this instance gets these settings, in this environment it gets these settings by default, and globally it gets these settings. Just kind of initially why I implemented something like this. It'll just kind of look through those dictionaries in order to find the key. So here we can implement something which is just a stack of dictionaries, and it's great. So we have our dictionaries here. It looks for a name, finds it. Oh, it's PyCon in Ireland. Great. If we look up something else, misc, woot, greeting. Great. So this works fine, but I'm talking about magic methods. Why don't we actually make it more like a dictionary? So if we just do something as simple as change this to get item, then all of a sudden, well, that one fails. Oop. So now it's more like a dictionary. We can just index into it, greeting, misc, name. Oop. Shoot. So this is, it lets us be a little bit more concise. So we can just kind of stitch together things using our fancy f-string formatting right here without having to basically repeat lookup. And why call it lookup when we can just use brackets, which are kind of more natural. So it's kind of like a dictionary, and we can pull stuff out of it, but we can also improve it so it even looks more like a dictionary. What's the length of it? 3 might make sense, just because there's 3 unique keys in it. Can we get the values in it? No. Can we see if a name is in it? No, not really. And maybe if we wanted to JSONify it, we could just wrap it in dict. But so all these are failing miserably with kind of strange errors. This one's, there's no length in it. There's no values in it. But without implementing every single kind of method of a dictionary, Python can help us out here with the abstract base classes for containers. Actually came up much quicker than I thought. I heard chaos engineering. I was thinking, oh, if you want chaos network engineering, you should just use conference Wi-Fi, which is horrible. So this is kind of the abstract base classes that Python uses, which are generally, if you want to pretend to be another thing, you should kind of follow this. So if you want to be a container, it has contains. The ones that are maybe we're more familiar with would be right here, set, which is just a set. A list would be much more like a mutable sequence. Sequence is if it's just read-only. Mutable mapping is our dictionary. And those are kind of the key 3, but it's also common just if you want to be a little lazier, you can just, will be a mapping. You can read items out of the mapping just fine. So what happens here, though, is that if we implement these abstract methods and then declare ourselves to be this abstract base type, or abstract base type, the ABC mixin will basically implement all of these other methods for us. So for our mapping, if we implement these three, then we get all of these. And then we can look much more like a dictionary with keys, items, values, get, etc. So let's flip back to that, if I can figure it out. All right. So yeah, we'll import collections.abc. Word of warning, this would kind of work right here, but it's changing in, I think, Python 3.8, which is coming out tomorrow. I don't know, so just use the full ABC here. So now what we can do is basically grab the same init and get item from the previous one up top, declare ourselves a mapping, and this right here is a helper, but then we can use it to define length and iter. So all keys is basically, like, this is our custom code, but length is basically returning an integer as we'd expect, and iter is iterating over all of it. That's how we need to define them, so that way they're consistent with how the dictionary would work. So now when we basically create our new object with those same dictionaries up top, now we can iterate over them. So this is hitting, we can see the length is 3 as we wanted. We can iterate over it to get keys as we would normally get out of a dictionary, not key value pairs. But we can also put that same iterator with values into a list. And we didn't implement values. If I do items, we didn't implement items either. All of these were basically given to us for free just by using that mixin. Or even just listing it by itself for the keys. Again, contains is name in it. We did not implement contains; it's doing it for us. And then if we want to basically pump it into a dictionary, so the dictionary constructor is intelligent enough to see that it's a mapping, and instead of pumping it out as just keys, then it actually kind of gets the items out and then constructs the dictionary for us. And then also the equality operator, again, and not equality. Right, yeah, so containers. So anything that you have that might represent something that's like a collection of items. For instance, in Django, you have a bunch of database records. You can, I haven't used Django in a while, but you can, I think, index into them. And just kind of a lot of the syntax that you can use is something that allows you to be a lot more expressive in Python and separate out what, how to actually do the thing, how to get the first record, how to get the last record. And then you can take care of that in this function, and then when you actually use it, it's much cleaner just to read the kind of overall logic of your code. And that's kind of it's the main through line here. Hopefully one of these will be useful for you, and I challenge all of you to try to go implement at least a few of them. If nothing else, implement repr. It's great for debugging. All right, on to kind of jumping tracks a little bit. We'll do some mathy magic. So here's the binary operators that I discussed. All the big ones are in here. And then also unary prefix operators. There's also invert, which is a bitwise inversion that I forgot to add here. And it's it basically would act just like you think. Right here, if I'm adding numbers, this is what's going on kind of behind the scenes. So we can also kind of tweak them a little bit to do other clever things. So I don't know if have people started using pathlib. I don't know if that's popular, or I don't know, pathlib versus OS path. Okay, one person. You're my man. Yeah, so let's kind of DIY it ourselves. I did know about pathlib before I implemented this one though, so I will have you know that. Here we can implement a repr that makes sense for us. We're being super introspective and using self.class.name, which will tell us who we are, even if our name changes. And then this verbose method is a helper that will just kind of show what's going on with the calls. So when I do path A / or path A with path B, then it'll basically stitch them together for us. And we had this call right here, so it called trueDiv, stitched them together, and then we got this output, which is great. So internally, it's doing the same as this, but if we have just like a slash there, it's hopefully a little bit more clear versus us like needing to do this method. And if we like chained it, we need to like do okay, like trueDiv. Like we can continue to chain it, but this gets kind of messy. Versus if we were just to like dupe this here, it'll do the same thing for us as well. So which is better, right? This is kind of the argument too for like adding mapmul into the standard library, even though nothing uses it. Purely just like writing matrix functions, they look sensible. In NumPy is like infinitely easier if you can just do at instead of the thing dot like with DOT, and then like just method calls after method calls. You can just kind of build them up much quicker without just like it being impenetrable like this guy right here. It's like it hurts to look at. All right, so there's kind of a shortcoming here. It will only work when all the parts are path objects. So if up here, if I just said like CCCC, this will die miserably because it expects it to be a path, which is not, it's maybe a little hostile if we need to like force the user to do it themselves. So instead of basically assuming that the other one is going to be itself, we can kind of check it out. Excuse me. See if it has like the path. If it's an instance of ourself, great. If it's not, we can just kind of assume it's a string. There's perhaps cleaner ways to do this, but it'll stitch it together. So now with this kind of like better B iteration, we can stitch them together just fine here. So and then we can stitch on furthermore or additional components to the path. And like look how clean this is. It's getting better and better all the time. There's also perhaps some minor shortcomings here again. So if I start off with a string, and I don't know if like the pathlib actually does this. This is instructive. If we do this, what will happen is it will also get confused because the string doesn't know what's going on. The string itself doesn't know how to divide itself in with this weird other thing. And this is kind of a similar thing right here, where it's it'll try to do this component first, and then the result of that, with like just the kind of operator precedence chaining, same as that. So what we can do is use reflected methods. So that was like if you remember on the first slide, there was this kind of like first column, which were the like normal methods, and then the second column was like all those other methods. So what happens here is that it'll try to do it one way, and then, for instance, like with the string/path, and if it doesn't know what's going on, it will try to call it the other way. So like, we can just do that with like numbers here. If you notice this like 2 r sub 100, it's flipping them around to actually do the subtraction, or 2 divided by 100, but like backwards. So like if I delete the trueDiv here, it flips it around. So it's just the arguments are getting flipped because one way might know how to do it, or it'll try the other way. So something kind of like this. It's a little bit more involved than right here. It'll check like subclass types for you. I suggest to check this link if you're interested. Yeah, so like what we can do is also try to implement that ourselves. So we'll extend path B further to implement the kind of reverse method. And if you notice, self and other, but down here we're gonna flip those around a little bit and do other and then self. So that way now when we do it, it will call them, with the bin string right here as the argument into this guy, but with the reverse trueDiv. So it's flipping everything around a little bit, but then we can actually get at what we want. And then now we can stitch together all these paths. We can mix strings, we can mix other paths into it. The order doesn't matter anymore. And yeah, great. And then kind of one more extension to this, because right here we're talking about paths. And because off-stop path-like is something that's still relatively new, it lets you use the so pathlib.path was nice and fancy, but then you couldn't pass it into if you just pass it into pandas or pass it into Django, it might barf because it expected it to be a string and not a this path object. So Python, we implemented os.pathlike, so that way paths are pathlike, and then you can basically pretend you can pass them into as you would any other thing. And then once we do that here, we will just implement fspath, which converts the object into just a string or a path for the operating system. Then we can go ahead and open it. So here I'll just look at my git ignore, which is pretty boring. I generally put my git ignores in the repo, and they're kind of messy, but I don't know. Yeah, so that's pathlib, but just use pathlib. Pathlib is much nicer and everything else. So, all right. What else do I got? Ooh. So ordering, this is also another thing that sometimes is useful if you're creating maybe like a cache of some sort, or here we'll just kind of compare a bunch of versions, which might not have a very easy order themselves. We can sort versions, and of course 0.93 comes after 0.94, but 0.9 comes after 0.10 maybe. I don't know. I think this is also why Python 4 will end up being just one more than 3.9. Horror. So we could actually kind of come up as many of us may know, there's a key argument to sorted, which is very nice. We can pass in just this kind of lambda that will split it up for us, and then it does actually sort it correctly. But what if we wanted to maybe encapsulate that logic within the object, the record itself? So what we can do here is implement a less than operator. So then when we do is this version less than this, we can actually kind of check that out. And everything, see that version 10 is actually less than version 9, versus if we did a string comparison. You'll notice that, for instance, we can't do less than or equals, because that will be, again, a separate object, or a separate method. But even immediately right now, yeah, sorry, out of order. But what we can do is if we implement equals, and then furthermore we can use total ordering, which is this little mix-in as well. We can do all sorts of all the operators all at the same time. So even though we only implemented less than and equals, any comparison right here, Python will do for us. If you notice right here, it's less than or equals. It's actually fusing together both of those. It's calling us twice. It's slightly less efficient. So if you have a ton of these, you'll probably just want to literally define all of LT equals greater than or equals, etc. But if it's quick, you can just use this. And yeah, from that we can create a bunch of versions right here, and then if we sort them, and we can see that it's calling less than on all these to do all the comparisons, and then we end up with a sorted list that's correct. And because we define this operator, we can use maximum, we can use minimum. These both have keys, but what if we had something that did not take a key argument, for instance, the heap queue object? So I'm going to use heap. No? Okay, yeah, it's okay. It's more stuff we can learn right here. So a heap is a partially ordered or a kind of pile of objects. If you want basically just the lowest item off of it, using a heap is faster. If you want to do it maybe a couple times, not all the times or not just once, but somewhere in the middle, a heap might be the data structure for you. So we can see that right when we heapify our list, it calls a bunch of less thans, and then we can heap pop is basically pulling off the lowest value again and again, and it restructures the heap to maintain, when we pop it, we're always getting the lowest. So we can see that here in among the calls, it's actually popping off 9.4, 9.34, 10.5, 10.42, isn't that great? So But this is, so we actually needed to implement this less than because heap will not, there's no key argument in here that we can use. It's just, here's the list of items. And I guess as kind of like I've been working in this notebook a while. There's also kind of more proprietary types of magic. For instance, NumPy has like an array spec. There's a method that you can implement on objects which will kind of allow efficient copying of data between them. That's kind of boring, so we'll do something that's a little flashier here with XKCD. Has anyone heard of that? My man? Cool. So there's these rich display methods. So if you like using IPython notebooks, and I like using IPython notebooks for even like sysadmin stuff, which is kind of weird. But you can implement SVGs, like PNGs, HTML. If you've used pandas, you notice it pops up as a table, a nice table of data. That table is implemented with the repr HTML behind the scenes, which lets you basically just pump in HTML into the browser and it shows it, and you can read it a little easier than if it's just kind of monospaced text. JavaScript, if we're using Bokeh, I don't know if it uses JavaScript or HTML with JavaScript tags in it, but kind of all the stuff we can just kind of dump in and it will show it for us. So I have this little just kind of helper tool that gets us links. So what we can do here is, we have this object that uses repr PNG, and all we do is return just PNG data out here. This is just raw bytes, and then what will happen is the notebook will, basically pull up our object, look through, all the kind of rich display methods that it supports, like all these reprs, and it'll be like, oh, does it have SVG? No. Oh, but it does have PNG. I'll call that. To show it, and then it'll basically just show a PNG in the browser, which is great. So when I was talking about the C. elegans that I was giving drugs, it was really handy because we're sifting through just piles and piles of video. I could basically load up a video, maybe overlay 2 frames, color them a little bit, and then just show the frame right in the browser, with kind of maybe zoom in on it. So if you're kind of manipulating lots of data, it's a really nice way, just when you're kind of debugging. It's what's going on with this worm? Oh, it's touching another worm. That is weird. So yeah, right here, I don't know if anyone has their favorite XKCD comic, but now this XKCD viewer, we can just index into it. With this, and it will just pull up the comic. So I don't know if everyone's seen this. I think if you just import anti-gravity in the REPL, it'll open the browser with this. 327 is also fun. I don't know. Does anyone have a number I want to shout out? You don't know your favorite XKCD comic number? I hear whispering. No. 1,000. This is clean, right? So yeah, the other ones I cheated and I already cached. So yeah, conference network. Oh, okay. Sweet. Yeah, so that's that. Yeah, hopefully you can make use of this. So I don't know if there's. Yeah, I can keep going because there's more magic methods that I haven't discussed. But I don't know if anyone wants to. If anyone has questions, I'd love to hear it. If you want to hear me talk about your favorite not context manager, magic method, you sir.
I have one question about the path one that you made.
Yeah, question about the path one.
Is it a recommendation to use the magic methods for overloading? Because I was just going in my head. So you have divide plus times. They're all defined as string. So then you have associativity and precedence, and it becomes pretty tricky pretty quickly.
Yeah, so I don't know if everyone over there heard, but should we be using these? Should we be overloading these methods to actually manipulate paths? yes, like this way lies possibly madness, and what we don't want to do is basically make people's life miserable that are using our libraries. For instance, like pathlib though is like pathlib is fairly restrictive because you can only do like just truediv, and I think the associativity direction doesn't quite matter with it. It'll always I think be like left to right with how it's processing it, but yeah, it's like I could define some path where like plus does one operation and division does another and subtraction does a third. So it's really like you need to kind of use what you're manipulating, and just make sure that it like feels good. 'Cause yes, you can be a miserable git with this. Yeah. So like unless you're on Windows, yeah. I think just to like wrap up, yeah, it's like yes, I will. My GitHub is just Nick Timko. I think this talk it'll just be under like talks magic methods. Yeah, right there. If anyone, I was trying to push, but again, wireless is a little sketchy right now. Yeah, this will be up there. A link to this, my notebook, and then some other kind of supporting materials I had behind the scenes. So if that's it, if no one wants to try to, call me out on do you know that method? Because I might not. Yeah, that's it. Thank you very much for attending, though. I hope you have a good day.